Welcome to Innova World.
Today our topic is aircraft longitudinal dynamic mode. We'll see some solved problems. Come to the first question. The eigenvalue of a characteristic equation for the longitudinal dynamics of a certain aircraft is lambda 1, 2 equals to 0.25 plus and minus 3.071 I. Find the nature of the system. Now here are the four options: whether it is dynamically stable, neutral, unstable and doesn't exist. So see first here the hint. Here remember this characteristic equation, that is lambda r plus and minus lambda imaginary I. Lambda value, that is lambda r, is a positive value. That means the system is unstable. So answer C, dynamically unstable. Now next question, match the following. See here we have some sets of aircraft modes and properties. So here you should know that what is mean by the short period mode. Short period mode, here we have a speed remains constant, and Phugoid mode where the angle of attack remains constant. So see the options, either it can be of F4 and H2. Either the options can be B or C. Now you check it out, the other one, Dutch roll. So what is the function of Dutch roll? It is a coupling between the roll and yaw oscillation. So I is 1. So B is the correct option. Next question. An aircraft is in a straight and level flight at a constant speed v. It is disturbed by a symmetric vertical resulting in a Phugoid oscillation of time period t. Assuming the g is the acceleration due to gravity is given approximately by. Now here you have to find how this g and v are related in terms of time period. Recalling this t formula, that is t equals to root over 2 pi v by g. You should remember this formula. So once we know this formula and pick out the correct answer, that is answer is D. Now next question, the undamped natural frequency of the Phugoid is a function of. So recall the formula again, that is undamped, that is omega n equals to root over 2 g by u. The u is a flight velocity. You should remember this formula again. So once we know that, that is undamped is proportional to that function of a flight velocity only, and g is constant. Next question, an aircraft in level flight encounters a vertical gust which excites the Phugoid mode. The Phugoid motion completes 10 cycles in 50 seconds and amplitude reduced to half of its maximum value in 25 seconds. The eigenvalue of the Phugoid mode are. So these are the given options. Now let's look after the solution. So this first, the given data, it is a Phugoid motion. Now what is the given data? That is the cycle, that is half cycle is a 10 cycle, and for the half time period is 25 seconds. Now we know that, that is characteristic equation, that is lambda equals to lambda r plus and minus lambda I of I. So you know this, recall this formula, that is t half equals to 0.693 divided by modulus of lambda r. So we know that t half, that is 25 seconds, and we know this, so from there we can retrieve the value of lambda r. So as per the given solution or given options, this can be the C can be the right option. Next question, the root of the characteristic equation for a longitudinally dynamic of a certain aircraft are, they have given two lambda values, lambda 1 2 and lambda 3 4, where I equals to root over minus 1. The pair of eigenvalues that represents the Phugoid mode is. So among this we have to find the correct option. Let's see the solution. They have given the two lambda values, that is lambda 1 2 and lambda 3 4, and we know the formula how we can find the natural frequency, that is this is the undamped natural frequency. Remember, when there is a omega n, that is an undamped. So there is a formula, that is lambda r square plus lambda I square, that is power 1 by 2, or rather we can say root over lambda r square plus lambda I square. So from there you can find the undamped natural frequency. From here you can find the damped ratio, that is tau equals to lambda r by omega n. Now if you substitute for this the condition 1 and 2, you will get these values, and when you find for the 3 4, you will find this value. Now comparing this two value, you have to note it that Phugoid, as per the definition, Phugoid has a low frequency compared to the short period mode. So which one having a low frequency among this? That is omega is 0.201 and other omega 3 4 we are giving 3.607. So obviously the lambda 1 and 2 will give the low frequency. So here they have asked a Phugoid motion. So obviously the answer D. Next question with the same kind of question. Here they have given the lambda 1 2 and lambda 3 4, and from here you have to compare the datas and find the short period mode damped frequency. So here you have to find the omega. Let's see the solution. Solution, here we know this lambda equals to lambda r plus and minus lambda I of I. You know this is this we have chosen at the minus 2.5 plus and minus 2.6 I as a short period, because we know compared to these two datas this lambda r value is high, so obviously we know the high frequency. Now you know this formula, that is a damped frequency they have asked, that is omega d equals to omega n, open the root over 1 minus tau square, or we can use the other formula also. Now how we can find omega n? Previously we have found out, that is lambda r square plus lambda I square power 1 by 2, and damped ratio already you know that. Now substitute on those formulas, you get the result. Now substitute on the damped formula, you get this 2.6, and from you can that you choose the right option. Next comes the next problem. The roots of the characteristic equations of a longitudinal dynamics of a certain aircraft are lambda 1 2 and lambda 3 4. Again it has been given. From again you have to compare the data, which one is going to be a Phugoid mode. Now from that Phugoid mode you have to find the number of cycle to a half amplitude for a Phugoid. So there the options comes. Now let's see the solution. Here are the given data. From here you know that what is mean by Phugoid, which will have a low frequency. So obviously lambda 1 2 will be the answer. So from the lambda 1 2 you can get, that is what is omega n, that is undamped natural frequency for it. And from there you know the formula for number of cycles to half amplitude. What is the formula? That is capital N 1 by 2 equals to 0.110, open a bracket, lambda I by modulus of lambda r. The modulus represents that if you have a negative terms, it will become a positive. We should not take the negative value. That's why we are using the modulus of lambda r. So once you substitute those values on this formula, you get 1.374, and that's a answer C is a right option. Now next comes the next question. The damped of a Phugoid motion can be improved by. So recall the formula, that is damped ratio, that is tau equals to 1 by root 2 L by D. So tau is inversely proportional to the lift to drag ratio. So if the damping ratio has to high, the lift by drag ratio has to low. So answer A is a right answer.
Lecture prepared by Miss Aishwarya, Department of Aeronautical Engineering. Thank you for watching.